Okay, students, so we are going to start exercise 2.2. Okay, so before starting this, I want you to see all those derivation also which I have done in the last class, because your first question is all about derivation only. Okay, so see here in trigonometry what is very important. First thing is rule. The identity which is given, you need to know all the identities properly. Not only class 12 identities, the one which we have done in class 11, those are also very important. And I told you in the last class only, that I mean last year only, in class 11, that all the identities we will be discussing in class 11 will be totally linked in class 12. Okay, so right now, don't think that the identity which we have derived, only those we will need. From your normal trigonometry, all the identities we have done last year, we will need those things also, okay? So without those identities, it's not possible to solve inverse trigonometry, okay? Because I told you, inverse trigonometry, whatever problem we will do, mostly is with the help of normal trigonometric function. You might have seen inverse trigonometry identity also I have derived from the normal trigonometry function only, right? So same with this also, and I told you that very few identities given to you in your NCERT book. Now in your exercise, one identity itself is given as a question. You can see in the last class I have derived the identity twice tan inverse x. This is what from which normal identity I have used. You can see this normal identity is from twice angle. Remember in class 11 we have done double angle, like for example sine twice theta, double angle, then cos twice theta, then tan twice theta we have done, right? So these are the double angle we have discussed in class 11, right? Even cot twice angle also we have discussed, right? These are double angle formula was there. Same way triple angle, that is sine of thrice theta, 3 theta we have discussed, cos 3 theta we have discussed, remember, tan 3 theta we have discussed. So for that also identity was there. So you need to know all those identity. Without that you cannot do inverse trigonometric function. Okay, so sine thrice theta identity was 3 sine theta, then minus 4 sine cube theta, right? So how you used to remember is, the way I remember is, in trigonometry function you know that sine theta used to always get priority, right? Then comes cos theta, then tan theta. So when it's sine theta, number will be like this. See, 3 4 in sequence, okay, 3 4. Then for cos theta, number will get reverse, 4 3. See, it is from smaller to bigger, bigger to smaller. For cos, reverse. And cube is in the second term, and in cos in the first term. That's what you have to remember. Okay, sine 3 theta, both will be sine. The terms which you have in both term, it will be sine. For cos. The number priority is given to first sine theta. The way your number in sequence it goes from lower to higher order, it will go like that, 3 4. Then for cos theta, 4 3, reverse it. Okay, so this is how I used to remember. And moreover, I have also told you the derivation of this one, right? So anyway, so you need to know all this identity. Without this identity you cannot judge how to solve inverse trigonometry. Not only inverse trigonometry, but you will need this one in calculus as well. Okay, calculus, remember, base is trigonometry. Without trigonometry you cannot do calculus again. Okay, so for calculus you need to learn trigonometry very well. So see here, when you will solve inverse trigonometry, first thing you think in the question, if there any identity I can use or not. Rules, identities you can use or not, just check in the question. Okay, if not, then think substitution. Substitution can I do or not? Now this substitution is very important here to understand, and this substitution you will know only if you know the identity very well. Okay, in calculus also substitution will play a very important role there. Okay, so if you know how to substitute, you will find it very easy. If you don't know, means if you don't know the identity first, then obviously you will not know how to substitute also. Okay, so for substitution your identity must be very strong. Identity you need to know very well. Okay, So in this question also you can see thrice of sine inverse x. I don't have any identity right now. We have not studied any identity. Now see what you have to prove. You have to prove that 3 sine inverse x is equal to sine inverse 3x minus 4x cube. So you can see this is what thrice sine inverse means what, and you can see on the right side also, does it look like any, here I cannot use any rule, right, because I don't have any identity. Those identity I cannot use here. So what is the only option is, you can see this, does it like look like any identity in normal trigonometry? Can I do any substitution here? So you can see thrice of, in place of x if it is sine theta, in place of x if it is sine theta, then it will be 3 sine theta minus 4 sine cube theta. Does it look like identity or not? Yes, it is the normal trigonometry identity I'm talking about. Okay, this looks like normal trigonometry. Here, first thing in this question, I don't have any identity in inverse, this one. So I cannot use inverse identity here, right? So what is the option left here? So substitution can I do? So here what I will substitute, I don't this does not look like any identity or any formula in normal trigonometry, right? But this portion, and from this only you can understand thrice. Yesterday class, when it was twice of tan inverse x, double angle formula, remember? See, sine double, cos double, tan double. When you do from that normal trigonometry, sine double, cos double and tan double, you just see the derivation which I have done yesterday. If you have understood that one, then easily you will understand this also. The derivation I have done from this formula, I have derived from double angle. So from this, whatever was the formula I have derived from there, I have substituted. Like for example tan, this was for 2 tan theta by 1 plus tan square theta, right? So this tan theta I have substituted, and then sine I have brought this side, I got this formula. Okay, here also tan I have substituted by x, and then cos I have brought this side, I got the formula. Same way here also you can do. Okay, in this C I will show you two ways, one simple way, the other one the usual one, derivation one. So see, your formula was what? Now how I know that this formula I have to use? Just by looking at the question, I knew that I have to use sine 3 theta. What was the formula? Formula was 3 sine theta minus 4 sine cube theta. How I knew that I need to use this formula? This I have judged from the question. Again I told you, you need to see the question and have to compare with the normal trigonometry function. The moment you will see this one, you must be able to figure out that this is normal trigonometry identity. Okay, so if I substitute this x by sine theta, this will become identity. So see what I will do. In place of sine theta, if I substitute x, okay, let sine theta is equal to x. So if I substitute x here, what will be your theta? Implies theta is equal to how much? First thing, sine, bring this side, sine inverse x. I have to convert. Remember the derivation how I've done. First I have written the normal trigonometric identity, and then what I have done, everything I have converted into inverse. This also, this also, this also, everything I will convert into inverse. Now to convert, what I have to do, I have to see in your formula what is there, sine inverse this. So this is what, if I put here x, it will become this one, right? This portion. Now along with this I need sine, means what, this sine I have to bring here. If I bring this sine here, it will become sine inverse this. In bracket, what is there? 3x. So just sine theta I have to replace by x, right? So that's why I have let it sine theta equal to x first. So if I let sine theta x, what your right side become? 3x minus, let me mark this one as 1. You need to see the derivation and don't be afraid of this kind of question. You might be thinking that it's very tough. It's not tough, it's just you need to practice little. Trigonometry is like that only. At first everything seems to be very tough. Okay, the moment you'll keep on practicing, you will see that it will be not that tough also. Okay, it just depends on your practice. So see here, 3x minus 4x cube. Can I write? Sin theta I have let it out x, right? So in place of sin theta I have put this one. Now don't put x here or 3x here. This is not sin theta, this is sin 3 theta. Some student used to get confused and used to write here 3x like that. This is not 3 into sin theta, this is sin 3 theta. So in place of this one you cannot substitute this. Okay, so what I'm going to do, see here carefully, sin 3 theta, exactly same way I have derived the yesterday's formula. Okay, so see from here what I need now, see sine inverse, right? Means what? Sine inverse, sine if I bring this side, automatically right side you already got it, 3x minus 4x cube. Can you see? So what will be left out? 3 theta. Now see in your right side what is there? 3 inverse is there, right? Theta we have defined ourselves. In the question it is not there. Okay, so this theta, that's why I have converted in terms of inverse. Can you see? Theta will be what? Sine inverse x. So in place of theta simply I will write sine inverse x equal to sine inverse 3x minus 4x cube. So very simple question, right? But the thing is you need practice here. Okay, so this is proved. Now another way you can do, another way of substitution, or so see here I will show you both. See how I will do it. Now I know that in place of x if I put sine theta it will become sine thrice theta, right? So instead of writing like this directly I will put sine theta there. See carefully. Let me write question again. 3 sine inverse x, you can write in this way also, sine inverse 3x minus 4x cube. Here only I will substitute in the question. So right hand side, let me write down, let x is equal to sine theta. I know that in place of x if I put sine theta it will become a formula, right? So right hand side, see what it will become. I will solve now. Right hand side, 3 in place of x sine theta minus 4 sine cube theta, right? Now sine inverse this, what it is, sine thrice theta, right? Now can you see sine inverse? Now obviously we are discussing about inverse, means here whatever angles come out it will be for defined function. Okay, inverse function will exist for sure. So what can I write from here? Can I write 3 theta sine inverse sine theta means what? Sine inverse into sine theta, remember identity, sine theta, what we used to write, it seems like this get cancelled and we used to get theta answer, right? Same way here 3 theta we got it, right? Now theta, what I can write, theta sine, if you bring this side it will be sine inverse x only, right? In place of theta I can put sine inverse, which is equal to nothing but left hand side. So this way also you can write down. Steps are very less here, okay, but this is the actual way to do it. Here we are deriving the formula, this is actually identity, this question itself. Okay, but in your NCERT this is not given as identity, but in your competitive exams and all you can use this one as, I mean in your entrance exam, this one as identity you can use. Okay, 3 sine inverse x is equal to sine inverse 3x minus 4x cube. Okay, so this was the derivation. So now question number 2 is exactly same. You try with both the method, okay, and see whether you can do it or not. Exactly same way you can do question number 2. Okay, so I'm not going to do question number 2. Let's move to question number 3. Now question number 3 is very simple. So you can see what it is. Tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2 I have to show. Now tan inverse 2 by 11 we don't have, 2 by 11 we don't have any trigonometric ratio value, right? Like this trigonometry ratio we don't have something like this. We have 0, 1, 1 by root 2 like that we have, right? But this we don't. So obviously tan inverse 2 by 11 you cannot solve. We don't know how to solve this one right now. But see here in your left side it looks like identity. Now inverse identity we have discussed something like this. See here, tan inverse x plus tan inverse y, this kind of identity we have already discussed yesterday. Tan inverse x plus tan inverse y, what was the formula? Remember, this is like tan a plus b. In your normal trigonometry, tan a plus tan b, tan a plus b, what was the formula? Tan a plus tan b by 1 minus tan A tan B. So in that way you can remember this. Tan inverse, in place of tan A tan B, you just put xy. X plus y, tan A plus tan B by 1 minus tan A tan B. This is how I used to remember the formula, okay? And derivation I have already shown you, okay? So I'm going to use that formula only. Tan inverse x plus tan inverse y. So left hand side is equal to tan inverse 2 by 11 plus tan inverse 7 by 24, which is equal to, can I write, tan inverse x plus y. X plus y means 2 by 11 plus 7 by 24 by 1 opposite sign minus tan A tan B, that is x into y. Okay, so you need to solve this one. I think solving will not be an issue, so you can solve this one, take LCM here, and then solve this one. This also take LCM and solve, okay? Then what you will get here is tan inverse. After solving, you will get whatever is your right hand side, that is 1 by 2, which is equal to right hand side, okay? Very simple question, this one. Simply using identity, you can get the answer. So question number 4 is also exactly same, okay? Same identity, you use it, you will get the answer there also. But the only difference is, let me show you a little bit. Twice tan inverse 1 by 2 plus, you might be thinking that twice is there, then also you will use same, like exactly same way you will use, right? But don't use exactly, but see here. It is given twice inverse 1 by 2 plus this one. Your identity is not like that. It was tan inverse x plus tan inverse y. There was nothing coefficient with tan inverse x, okay? So but in this case 2 tan inverse. Now this itself is an identity. So I don't think it will be a problem for you. You have to prove twice of tan inverse this plus tan inverse this. Now this is double angle. Remember double angle formula in normal trigonometry, twice tan inverse x. Now which formula? In this case, three formula is there again. You can see twice tan inverse x, this. Out of these three, which one you will take? Obviously we will take this one. You just put in left hand side twice inverse 1 by 2 plus tan inverse 1 by 7. In this twice tan inverse, what formula you'll use? Better use this one. Why? Because if you use this, what will happen? It will be like again identity. Tan inverse, whatever comes out here, take it as x plus tan inverse y. Then use that identity, first identity which I have used here. After that, exactly same way you have to do. So only the difference is they have make it here twice tan inverse x, okay? So in place of this one, try to use the identity this. Don't use this or this, because if you use this one, it will become sine inverse here. After that it will be a problem, because tan inverse 1 by 7 we don't know how to solve. What is the value? So sine inverse whatever comes out, if you get the answer for that also, you won't get for this. So you cannot solve anymore and you cannot show it this one, okay? So what you'll do, you need to select the identity also wisely, okay? Otherwise you won't be able to figure out the solution here. Okay, so twice tan inverse x, you need to select this identity only. Then only you can see it will become again identity. After using that, you will get this answer. Okay.